Alrighty, welcome back. I'm gonna go ahead and finish the second objective that I skipped. The first video covers objective 1, identifying one-to-one functions, and then we also did objective 3, finding the inverse of a function. And the assigned problem for this week is gonna be very similar to example 7. So if I go back to Canvas real quick, I posted this on this folder, but both sections, Monday, Wednesday, or Tuesday, Thursdays, you guys will see your 3.1 problem in week 11 folder. It's called 3.1 problem, finding inverse functions. If you download it, you can print this out or you can write this down. I'm going to give you a function f of x. Part A is asking you to find the equation for the inverse function. So give me f inverse of x. And you're going to show about, each step, 4-step process. And you're going to have to solve for y. And that one is very similar to what we just did on example 7. And I want you to find the domain and range of f in inverse notation. And if I ask you to find the domain and range of the f inverse of x, then that's just going to be switching the domain and range of the original function. So part ABC, I'll ask you to try that. This is actually a page from my Unit 3 test from last semester. So I will ask you to do something like this, submit this. After, if you need to go back and watch this video, the first video where I go over example 7, it's not too clear, but let me try to circle all these answers. So the answers that I'm looking for are the inverse function, like this. And then I will also ask you to find the domain and range of the original and the inverse function, and then the range and domain of, each of those. So just make sure that you write these in the right folders. If anything is wrong and you submit it before this Sunday, please do that. Please don't submit it after or at 11 o'clock on Sunday, because I won't be able to grade it at that time. And if anything is wrong, the submission link will be closed and I'm not going to accept any correction work after that point. So submit it early, like Wednesday, Thursday, Friday, even Saturday, I'll be able to give you feedback. And if anything is wrong, you should be able to go back and fix it. But if you submit it at the latest, you wait until the very last minute to submit this assignment, then you're not going to have a chance of correcting it, okay? So make sure you submit this early. And these are the kind of work that, we used to do in class before you leave. But now we're going online. I'm giving you a little more time, but it doesn't mean that you have to wait until Sunday to start these assignments, okay? All right, let's go back to page 2. We only have one page left, where we are determining whether two functions are inverses. Now, what you have to do is you have to find the composition of functions, and you do f composed of g of x, in other words, let me write this down. You do f of g of x. You plug in g of x into f of x. And that needs to come out to be x. All right, so that's condition number 1. You need to meet that first. And then you check the other way around, g of f of x. And then that needs to also come out to be x. And only when these two conditions are met, both of them has to be true. Okay, both of them have to be true. If both are true, then you get to say they're inverse of each other, okay? So this is a great review of composition of functions. That's something that we talked about back in Unit 1. So let's try that. And then, this is just kind of talking about, the same thing. But let's get to it. A, I'm going to check and see if f and g are inverse of each other. Now, kind of looking at the function, I see that f of x is x minus 4, and the other one is x plus 4. Subtracting 4 and adding 4 are opposite operations, right? So I think they are. Yeah, they look like they're inverse functions. And we can check it by just maybe plugging a random number. What if I plug in f of 2? Oh, I'm sorry, f of 10. Let me just plug in 10 into f of x. Then that will be 10 minus 4. I'll get 6, right? So the order pair for that one is 10, 6. What I'm going to do is I'm going to plug in 6 into g, okay? 6 into g. I'm plugging in the output into g function. If I do that, I will get 6 plus 4, which is 10. So I will get 6, 10 for the order pair. And notice how these are just switched, right? So kind of a quick numerical way of checking, but you know, that's not going to prove, or that's not going to be the way where how we're going to determine whether these are inverse of each other. We're going to go and use this composition method, okay? So let's check the first one. You will need to check both ways, okay? So first, on this left side, let me check f of g of x. What do you want? If you do this composition, if you simplify, we need to see that it comes out to be x. If it doesn't, then we're gonna say, oh, it's not. These are not inverse of each other. So let me try. Plug in g of x in here. What's g of x? G of x is x plus 4, right? So plug in x plus 4 in here. Okay. Now, what we're gonna do is we're gonna evaluate f of x plus 4. So notice we're going to plug in this x plus 4 into this x. Okay, that's f of x, right? So that's going to be equal to x plus 4 minus 4. Okay, so once you write it down, you're just going to have to simplify this. Let's simplify this. That will be x plus, I don't need parentheses here, right? I'm just going to say that's x plus 4 minus 4. Plus 4 and minus 4 cancels out. Therefore, we just get x. Now, it passed the first condition. So we're good. If it passes the first condition, then we move on to the second. This is time for us to check g of f of x. We want it to come out to be x again, right? So let's plug in f of x into g. What is f of x? F of x is x minus 4. So plug in x minus 4 into g of x, okay? So this time, we're going to plug in this x minus 4. This x minus 4 is going into my g of x. So here you go. We're going to replace that x by what I just circled over here. So that's going to be what? X minus 4 plus 4, right? If you simplify that, you'll get x minus 4 plus 4, where the negative 4 and the adding 4, those will cancel out, just giving you x. So if both of these compositions come out to be x, guys, well, then you get to say, let me write the conclusion, Fn, Gr, inverses. No, is that a what? Inverse? Okay, I'm not going to say inverses. I will say inverse of each other. Okay, so let's try 3 more. Okay, and you will see sometimes they're not inverse of each other. Now let's look at B. In B, I see, just kind of looking at the different operation each functions are having. G of x is multiplying by 2 and then adding 3. F of x involves subtracting 3 and then dividing by 2. I think they got the opposite operations down. Like multiplying, I see multiplying by 2. I see dividing by 2. So those are opposite of each other. Adding 3 and then subtracting 3. Those are opposite of each other. So they may be inverse functions. But the only way of checking is when you do your composition. Let me do f of g of x first. F of g of x equals, and then we're gonna, let's see, what is g of x? Because what we need to do is we have to plug in g of x into f. G of x is 2x plus 3, right? That's going to go into f. Okay, so it's going to be a fraction with 2 in the denominator, but the new numerator is not x minus 3 anymore. It's going to be 2x plus 3 minus 3. Okay, I hope you're okay with the substitution. This is just composition of functions. All right, let's go ahead and simplify this. You know what? I think I just kind of did this all. Yeah, because I was going a little too fast. I usually write this first, right? F of 2x plus 3. I write that first, and then I indicate that this is going in there. But I just kind of did this all in one line. And I've seen some of you doing that on your exam last time. So I think you can do that. Yeah, you can handle that. Why not? All right, let's go ahead and simplify this. If I get the numerator out of the parentheses, I will get 2x plus 3 minus 3 over 2. Now notice the 2x plus, the plus 3 and minus 3 will cancel out. I will have 2x over 2. Now, 2, and then that 2 cancels out, so we will get just x. So when you check f of g of x, that one checked out. Now it's time for us to check the other way around. Let's check g of f of x. Well, that is going to be g of, let's write down f of x in here. F of x is 2x minus 3 over 2. Now we're plugging in this expression. This is going into where? This is going into g, and g is right here. So we're going to replace this x by this fraction, okay? So you ready? 2 times, not anymore x, but write down x minus 3 over 2, and then add 3. All right, let's see what cancels out here. Notice that the 2 cancel out over there. It's going to turn into x minus 3 plus 3. The minus 3 and plus 3 cancels out. Therefore, we only get x again. So check. When both of these compositions give you x, you get to say that Gn, Fr, inverse of each other. Okay? But you've noticed you got to check both ways. Okay? Make sure that you check both f of g of x and g of f of x, not just one of them. All right, let's look at 2 more. Ooh, this one. Now, look at this one for me. F of x involves multiplying by 5, right? How can you undo multiplying by 5? The inverse operation should be dividing by 5. I think they got something. They know that they're dividing, but we should be dividing by 5, not dividing by x. So, it looks like they got the multiplication and division part, but I don't think these are inverse of each other. Let's check it, okay? Let's check this. So first of all, let's check f of g of x. Okay? So that's going to be f of, let's put g of x in here. G of x is 5 over x. So plug in 5 over x. And we're going to plug in this 5 over x into x. Okay? Into f of x. That's going to be 5 times 5 over x, right? Now, if you multiply this, because I don't want you to cross out those 5s. This is really 5 over 1 times 5 over x, right? Now, what's that going to be? 25 over x. That's simplified all the way. Is this x? No. Oh, I should say, no. This is not x. Therefore, guess what? It failed the first condition and needs to meet both conditions. So this is where you get to say, f and g are not inverse of each other. Okay? So, if it fails the first condition, then you don't have to go on and check the g of f of x, because it needs to be true for both f of g of x and g of f of x. And if one of them fails, then you get to just say, oh, they're not inverse of each other, and move on. Okay? All right, let's look at the very last one. Oh, look at this. It's 5 divided by x, and then the g of x also says 5 divided by x. Guys, they're exactly the same function. So can they be inverse of each other? We'll see. Now, I think it's going to make it a little bit easier if I rewrite this for you, okay? It's really 5 divided by x, right? I'll do it this way. And then g of x is also saying what? 5 divided by x, right? I'll write it this way, okay? Now, let's check f of g of x first. F of g of x is f of, what's inside? 5 divided by x, right? Okay, let's go ahead and plug this 5 divided by x into f function. So this is going in right there. So we can write this as 5 divided by, and this 5 divided by is just, I'm copying down the thing in front of it. Plug in 5 divided by x right there, okay? Maybe writing this as a divided by is confusing a little more. I thought this was going to help us, but it's a little more confusing to me. So you know what? Let me go back to the fraction notation at least. Maybe at least the inside part. That's really saying the same thing as 5 divided by 5 over x, isn't it? Okay? Now, you know how to deal with division. You keep, change, flip. You keep the first number the same. You change the division to multiplication, right? But what do you do with the second fraction? You flip it. If I do that, notice what cancels out. The 5 cancels out. Therefore, that just comes out to be x. Yay! So I just checked f of g of x, and it came out to be true, right? Now, I should minimize this work a little bit so that I can actually do the other one, okay? Give me 1 second. To get smaller. Okay. Maybe this guy too. All right, let's now try g of f of x. It's going to be the same exact thing because they are the same function. Now, g of, what goes in this parenthesis? 5 divided by x, right? Or, no, wasn't it easier if we just went with 5 over x? I'll do that. Sorry. I thought writing it as a division makes it a little bit easier to see. I think it did, though, because at the next step, the very next step, if I plug in this 5 over x into g of x function, that will turn into 5 divided by this fraction, 5 divided by x. And it was clear to me that I'm supposed to keep the first 5 the same, change the division to multiplication, and what do you do with the second fraction? You flip it. Keep, change, flip. And now what I'm doing just now is exactly the same thing as what you just saw, but I gotta check both ways, right? So it comes out to be x, so what do you get to say? You get to make the conclusion that f and g are, I mean, these are exactly the same function, are inverse of each other. Now, just out of curiosity, I want to graph this with you. All right, ready? I'm going to go to my Desmos app. I downloaded all these apps that's going to help me. I'm going to graph 5 over x in here. So y equals 5 over x. And then the other one will also be 5 over x. I don't have to graph it. But you know what the second line that I'm going to graph? I'm going to graph y equals x. Why y equals x? Because remember, inverse functions or one-to-one functions, is it appropriate for me to connect this with the one-to-one function? I mean, all the functions that we graphed are one-to-one functions, in fact. So maybe not. I guess I don't have to really do this, but why did I want to do this? I think I kind of wanted to show you that this graph itself is symmetric with respect to the line y equals x, but well, this symmetry with respect to x kind of applies to all the other functions. So maybe not just this one, but in fact, let me graph the first one that we graphed, really. How about y equals, what was it, x minus 4? Y equals x minus 4. Oh my gosh. Y equals x minus 4. And the other function was y equals x plus 1, x plus 4. So I graphed both of these functions, and the dotted line is the y equals x line. Look, the purple line and the black line are symmetric with respect to this line, y equals x, right? Let's graph at least one more, just so that we can see a couple other. How about if I graph, not this one, because C wasn't an inverse of each other. This one, let me graph this one. I'm going to take a picture of this so that when I go to my Desmos app, I know what function I'm entering. Okay, I'm going to go to my Desmos app now. Desmos. And I will this time graph. And what I'm doing right now is completely unnecessary, but it's kind of cool to see, don't you think? Y equals 2x plus 3. That's my first equation. And the other one was y equals, the second one was x minus 3. But hold on, these ones were in the numerator. So I'll say x minus 3 in a parenthesis, and then I will divide that by 2. Notice these two red and blue lines. Can you see the beautiful symmetry going on right here? The red line and the blue lines are symmetric with respect to the line, to the line y equals x. And if they're inverse functions, We should see that. We should see that, right? So that's what I kind of wanted to share with you. It wasn't only going to be the last function. In fact, the function itself, the y equals 5 over x, that graph itself is symmetric with respect to the line y equals x. The other ones, the f and g were symmetric, g and f were symmetric, except for c. You'll see how if you graph c, they're not going to be symmetric. All right, maybe just for the last one, let me do that. The last one, c, that didn't come out to be inverse of each other. The first one was y equals 5x. And then the other one was y equals 5 divided by x. Now, notice they're not symmetric. The purple one and the green one, they look, let me change this to red. The purple one and then the green one, the red one, they're not symmetric with respect to the line y equals x. So, you know, graphically, you can see that they're not inverses of each other, okay? So that's it. That was the only page that we did not go over in the first page. I think these will probably be more on the homework, and I'll talk about it more if I'm going to include this topic on Unit 3 exam. But I know for sure, definitely, you will need to make sure you know how to do example number 7, where you are writing the inverse function and actually finding the domain and range of it. So if you missed that part on the first video, you need to watch that, because you are responsible to submit. You are going to be required to submit this 3.1 problem where you have to write the inverse function, write the domain and range of f and f inverse, okay? So that's it for this week. Your 3.1 Alex homework is also due this Sunday. And don't forget to complete your scheduled knowledge check 3. Sorry that we got a lot of, knowledge checks, practice tests kind of, or the exam all lined up in the same kind of week. But I do need you to do these scheduled knowledge checks every once in a while in Alex, so that those random knowledge checks don't show up. Because after you mastering certain number of topics, Alex will ask you to take some kind of knowledge check so that they can just say you really mastered it, instead of just saying, oh, you learned it. So it's about time for us to complete that one. So I need you to do that by this Sunday too, please, okay? All right, that's it for the lessons this week. Next week, we'll talk about 3.2. And if you're confused about what's due this weekend, please check out the week 11 agenda, or you can just always email me, okay? Now, these will look a little different, depending on if you're on Monday, Wednesday, or Tuesday, Thursday class, but